So object detection, kind of 101. Who knows what object detection is already in this room? I think more than a few people were at an embedded computer vision summit. So object detection detects and classifies usually multiple objects, or it can do multiple objects in an image or video. And you can see it's kind of drawing these bounding boxes on those objects, so it's getting like XY coordinates of where those exist inside of the frame. And this really paves the way for so many other exciting applications in computer vision. When you get this, now you can do object tracking, you can count how many things are in a frame. It opens up the possibilities for computer vision to do a lot of really cool things. And for the deep learning architectures that we're going to talk about today, the data set you kind of need to train your own is a labeled image with these bounding box coordinates that you're going to feed it, and then the model's going to learn how to identify that object. So who has trained an object detection model before? 2 people, something like that. Who's made their own data set? The same 2 people, or 3 people now. So you know that like labeling the data can be pretty painful too, but also you learn a lot about your data when you're labeling. You'll learn so much about what your model is going to see and weird variations, so I definitely recommend that you do that. Why object detection matters, I kind of already mentioned, paves the way for a lot of things. I might reference like autonomous vehicles or self-driving cars a lot because I think it's a reference that a lot of people understand and can think about really well. And robotics, security, you can detect like where people are, if a bag has been left somewhere for a certain amount of time. When you have object detection, you can add in things like dwell time and like where things are within those images. When you're putting these out into the real world, you often have to think about a balance around speed, accuracy, and efficiency on low-cost devices. So with speed, is this fast enough for the use case that you need? So if you're doing a self-driving car and someone runs in front of your car, that has to be really, really fast probably to put on brakes. But you also need accuracy there. So you need really reliable predictions when you can get it. You often want speed. And then again, if you're putting on these like really small drones, or who has a Raspberry Pi laying around? A lot of people. Do you want to put a model on the Raspberry Pi? Who wants to put an object detection model on Raspberry Pi? I think everyone's nodding along. So I will talk about this and kind of how to optimize how you could do that. And then also, I'll have a link at the end with actual code that you can go and run. And so you can kind of implement all the things I'm going to talk about today. And I've tested, you can run it on a Raspberry Pi.